Here are the solutions to Part 1, Algebra 2 Final Review questions, starting with question 8. Question 8 is asking for the zeros of the following function: x to the 4th power minus 4x cubed minus 9x squared plus 36x. And when we have four terms like this, a lot of times we're going to be using a method called factor by grouping, in which we're going to group these terms together, and we're going to group the last two terms together. We're going to first look at the first two terms, and we're going to think about a greatest common factor of those two terms, which would be x cubed. So I'm going to divide an x cubed out of those terms. After doing that, I'm going to take x to the 4th power, divide by x cubed, and get x. I'm going to bring down the minus sign, and then I'm going to take 4x cubed and divide by x cubed, so that's just going to be a 4. Close that out. Then I'm going to look at my second two terms and factor out the GCF there, the greatest common factor. I could definitely bring down the minus sign in between, and I could take a 9 and an x out of each of the terms. I could divide that out. 9x squared divided by 9x is going to leave you with an x. 36x divided by 9x is going to leave you with a 4. However, it's important to realize that that was a negative 9, so that's going to be a minus sign in the middle. A positive 36 divided by a negative 9 is a negative 4. And when you do factor by grouping, you're going to notice that there's a common binomial term. In this case, that would be the x minus 4, since they each share an x minus 4. In front of that, we could have our other factor, which is x cubed minus 9x. I'm going to factor this even more, though, this first part, because if I have x cubed minus 9x, I could divide out another copy of x. And then we would have x cubed divided by x, which is x squared, negative 9x divided by x, which is negative 9, and then bring down your x minus 4. These are your factors. The question asks for the zeros, so I have to set each factor equal to 0. Right here is already 1. Over here, we're going to set this equal to 0 and solve for x by adding 9 to each side. X squared equals 9. If I want to get x alone, I have to do the inverse operation of squaring, which is taking the square root of both sides. X is equal to the square root of 9, which could be positive or negative 3. Remember how 3 squared is 9, but also if you have negative 3 in parentheses and square that, that would also be a positive 9. And lastly, set the factor x minus 4 equal to 0 and solve. X equals 4. Your roots are 0, negative 3, positive 3, and 4. And you have 4 of those zeros, which makes sense because you had a 4th degree. The fundamental theorem of algebra says 4th degree polynomials, like the one that we just had, have 4 roots. And we just verified that. Question 9. I'm going to show you question 9 based off of the actual document. You have this graph. It's a cosine graph, and you need to think about which of these is the right case. Our standard form for any cosine graph is y equals a times the cosine of bx, where a is your amplitude and b is your frequency. However, in this case, we're also going to need to know what the period of this function is. We find the period by using the formula 2 pi over b. Take your 2 pi and divide by the frequency. And in this case, we have to look at this graph. Right here, we start off having a maximum of 1/2, 0.5, and a minimum of negative 1/2, negative 0.5. So we definitely know that that amplitude has to be 1/2. Choice 2 and 4 are already eliminated. Now what we need to do is look at the period of the graph. And what that is the amount of time it takes for that graph to complete one full cycle. And that would be from here to here. And that happens from within pi radians. The period is pi. That's equal to 2 pi over b. The only value of b that works is 2. So your b value, your frequency is 2. All right, and then on the next page, we have question 10. If $5,000 is deposited into a savings account. That pays 3.5% interest compounded monthly. That's important. How much money to the nearest 10 cents would be in that account after 6 years. And this is assuming that you're not adding or detracting, you're not depositing or withdrawing money from the account within that time frame. And this is going to be a compounded situation, compounded monthly. The thing to pay attention to here is that they're giving you compounded monthly, and that's the rate. However, they want to know about 6 years. All right, so there's a special formula used for this type of situation where you have A, which is your new amount, is equal to P, the principal, the initial amount, and then you multiply that by 1 plus R, but that interest rate is going to be that's monthly, so we have to divide by 12 months, and then we're going to raise it to the to the n times t. N is the number of times each year, so it's every 12 times a year. That's the number of times that the interest rate is evaluated each year, times 6 years. So this is going to be A is equal to, our principal amount was $5,000. That's how much you start with. And then we're going to take 1 plus, you have to take the rate. So the rate is 3.5%, but you have to make that a decimal. And we do that by moving the decimal point 2 places to the left. Therefore, the R value is 0.035. So I'm going to take 0.035, and I have to divide that by the 12 months and raise this to the 72 power. Think about it, to the 72 months in a year, so that's what that represents. But the interest rate must be divided by 12. That's the number of times that each year is 12 months in a year. So now we're going to do this on our calculator. 5,000 times 1 . 1 plus parentheses 0.035, divide that by 12. So that's going to be this value here is going to be 1.002916667. Raise that to the 72 power. All right, so now we're going to take $5,000 times, and instead of rewriting all these digits, I'm going to use the second answer. That's going to give you the answer from the previous line. And I want to raise that to the 72 power, which is going to be that the new amount is $6,166.51. Which would be choice 4, since that would be, well, the nearest 10 cents would be 5, so that's going to be 6,166.50 cents would be the nearest 10 cents.